In this video I'm going to show you how you can find spare addresses for inputs, outputs, memory bits, timers and counters in Semantic Manager. So the scenario is we're at a machine and we want to create a modification, and we need an input, an output, and say 2 or 3 memory bits, maybe a timer, maybe a counter. Now for the 2 or 3 memory bits that we're likely to use, we'd like to keep memory bits together. For example, we'd want to use, say, memory bit 20.1, memory bit 20.2 and memory bit 20.3. There's no point using memory bit 1.5 and memory bit 100.7 and memory bit 2.6. They're spread about and it's going to get messy. So if we want to find what's been used already, what's available to still use, we use what's called reference data in our program. So here we have the program open, or the project open, and we're looking at our blocks for the project. If we go to options, reference data and display, there's various different options that you can see in reference data, and you may not see this view that I've got. You may see something like this with a list of addresses, or you may see the program structure, or you may see unused symbols, or you may see something like this. And what we want to look at for this example is the second block along, which is assignments of in and outputs, bit memory, timers and counters. And when we open this, we can see our inputs, outputs and bit memory and timers and counters that are used. So here we can see that timers 22 and 23 have been used, timers 30, 32, 34, 36 and 38. There's no counters used in this project. So if we needed 2 timers for our modification that we're going to make, it may be a good idea to use T48 and T49, or we could use T80 and T81, or T90 and T91, or even T108, T109, or we could use any of these spare blocks here between T50 and T79. If we wanted our 3 memory bits to use, let me scroll down till we get to our memory bits. So we can see that here that most of memory byte 2 is taken with only 1 spare bit, which is 2.6. We have options of plenty free in memory byte 3, all of 4, 5, 6, 7, 8 and 9 are free, half of memory byte 10, so there's plenty of options there, so we can nicely pick 3 areas where we can use bits that will stay together. If we scroll down more, you'll see things like here where a whole memory byte is utilized somewhere in the program. Here you can see again a whole memory byte utilized, whole memory byte utilized, and here you can see 2 bytes used. So here in the program a word is used 16 bits. Again, another 16 bits used here. So the table can come in very handy for referencing, and makes it easy to plan whatever you're going to do, whatever modification you're going to make. It makes it easier to plan, so you can choose your addressing and keep your program neat and tidy. Hope you found that useful. Come and visit us at learningautomation.net to find out more.